So today we will discuss about the combination of thin lenses, right? Combination of thin lenses. So for example, consider that this is our focal length, principal axis, and here we have a convex mirror which is known as converging, right? This is a focus point and this is also a focus point, right? Now consider that here is an object and it is very tiny, very minute object, and obviously the ray will go over here and then it will form a line at the focus, right? This is our optical center. Now here the image is formed, right? Now let's put another convex lens over here, okay? So what will happen? It will converge this image over here. This is its optical center. Now what will happen? Basically, this distance between optical center to the focus point is known as f, right? And this optical, there are two images, right? The image from this optical center to this is basically known as q dash, and this image formed is known as I dash. The image formed over here is known as I, and the distance between O to I is basically the Q, and this is Q dash basically, right? And the distance between optical center to the object is known as basically P, just P, right? So for the first lens number 1, like we know the formula is 1 upon F is equal to 1 upon P plus 1 upon Q. So here F is basically, this is F1, this is F2. So F is equal to F1, where P is equal to P and Q is equal to Q dash. Now the formula will be basically 1 upon F plus 1 upon P plus 1 upon Q dash. This is equation number 1. Now for basically the lens number 2, for lens number 2, we know that 1 upon F is equal to 1 upon P plus 1 upon Q, right? Now what will happen? F is equal to F2. Here P, which is basically object, will be equal to Q dash minus, because minus why? Because it is a virtual image, right? And here Q will be equal to Q, right? Now the formula will be 1 upon F is equal to 1 upon F2 basically equal to 1 upon minus Q dash plus 1 upon Q. So and this is known as equation number 2, and now we will combine these both equations. It will be 1 upon F1 plus 1 upon F2 is equal to 1 upon P plus 1 upon Q minus 1 upon Q dash plus 1 upon Q. Right, now this one will get cancelled and we will get 1 upon F is equal to 1 upon P plus 1 upon Q. We know that basically this is 1 upon F. We know that 1 upon F is equal to 1 upon P plus 1 upon Q. Now 1 upon F1 plus 1 upon F2 is equal to 1 upon F. So this is the formula to find the focal length for the combination of the thin lenses. Remember that the lenses must be same, not like if you have one concave and another convex, so this formula won't work over there. Thin lenses, right? So now let us discuss about the power of lens. Basically, power of lens is the reciprocal. This is the reciprocal of focal length, right? The power is inversely proportional to the focal length. So the formula for this, this power must be taken in meters. It must be taken in meters, right? So the formula will be basically 1 upon F meter, or if you are taking in centimeter and you don't want to convert this, so it will be 1 upon 100 upon F centimeter. If you are taking in centimeter and you don't want to convert it, you have to multiply the 1 by this, the value which you have. if the value is given in millimeters, so you have to 1000 divided by f millimeter. This will be the right. So now basically if we talk about the formula of power, it will be P is equal to P1 plus P2. This will be the formula of power, and here say P is equal to 1 upon F will be the general formula, right? If we want to find the combination, then this formula will be applied, right? If we talk about the unit, so basically unit is diopter. Diopter is the unit, and then and basically the length which we'll take will be always in meters, but the unit is diopter of this power of length, right? So I hope this is clear to you, this power of length and the combination of thin lenses. If you guys have any kind of queries, you can ask me in the comment section and be very glad to answer you guys.